The law is changing if you install central heating or gas boilers. My name's Hart, and in today's video I received an email recently from Baxi saying the law is changing and it's going through the new Part L document to conserve energy in properties. So I thought I'd do a video. We also had some in the community section, we're also asked if we could do a video on this new Part L as well. So I'm back today. I'm back at the National Gas Centre for Excellence, and I'm back with Michael. And Michael's going to go through this document and he's going to explain it on PowerPoint, and then he's going to go through and show you what that means to you and sort of how that will affect you with radiator sizes and things like that. So it's quite a long video today, but hopefully it will give you some guidance and help you a little bit. And then at the end, after Michael's spoken with you, then I'll recap on that and give you my opinion. Please put some comments below. As always, if you could put thumbs up on the video, really appreciate that. We've put a lot of time and effort into doing these videos for you. And if you want us to do any other videos for you on anything to do with central heating or gas, low loss headers, system design, anything to do with central heating, just put a comment below. Or even air source heat pumps, because we're going to be doing some stuff on air source heat pumps as well. Yeah, I'm babbling on. Without further ado, let's go over to Michael.
The law's changing. Is it really? Welcome to this video from National Gas Centre for Excellence. Today we're going to address a couple of things that have come out recently. We've received quite a number of people asking questions about the new guidance that's going to be coming into effect from June 15th this year with regards to low temperature heating design and how it affects us as engineers. So first of all, we need to understand what is it that's changing? What are we being told is coming into effect in June? Now, as an industry over the past few years, we've started moving towards low temperature heating. Heat pumps and whatnot are sort of leading the way in that sense. But now as an industry, and thankfully really, we're starting to recognise that low temperature heating, low temperature flow and return temperatures are much more efficient and create a more efficient system. So first of all, it's worth caveating that we are all for this at National Gas Centre for Excellence. We understand that low temperature heating is the most efficient way of heating a home. But this video is really just to give you guys an idea as first of all, what's happening, cut through all the red tape. Is it law? No, it's not law. Approved Document L is the document that covers the conservation of fuel and power. The conservation of fuel and power approved document L it's the same document that covered TRVs and zoning of heating systems and all that kind of thing. And it's all about trying to make it so that a customer's property or home is not wasting energy that it doesn't need to waste. The other side of it is that British standards, it's recommendations, it's guidance, it's not law. So when we're being told that the law is changing, it's not. It's best practice, and we should all be striving for best practice. However, this is not a legal obligation on you guys. The other thing to note though, just as a sideline to that, is that when a manufacturer sells you a product and advises you that it must be installed to the relevant British standard, then if you don't follow that relevant British standard and you decide not to opt for best practice, then you could go down the route of not getting the warranty that you've paid for, because the manufacturer might say, well, you never installed it to British standards, so therefore we're not warrantying the product. So what's covered in it? What's the new guidelines from June? What's involved in it? The first thing is it covers existing systems and newly installed systems. Now, newly installed systems are not just in new builds, they're also in existing properties where the customer's having a complete overhaul of the system. So the system's coming out and putting new emitters and heat source in and pipe work as well. And it's largely aimed at this low temperature model, which is great. It also has a little bit in it around about water treatment, but again, that's down to the relevant British standard. it states that every system must be cleaned thoroughly, which is great, and also that it should have a system filter, not must, should. However, again, the same rules apply with regards to warranties, etc. So, what else is changing? On new systems, complete new systems, they should be designed to a flow temperature of 55 degrees. Now that's whether it's a boiler, heat pump, whatever it may be, as a maximum really, at the same as a maximum of 55 degrees, but lower if possible. That's great for us, because we want to be fitting heat pumps at a maximum of 55 degrees, or boilers with a return temperature as far below 54 degrees as possible to ensure that we maximise condensing. The other things we need to think about are heat loss calcs. The document states that for any new installation we should be doing an accurate heat loss calculation. I'd go as far as to say this should be the case for whether we're replacing a boiler too. When we're replacing a boiler, that existing boiler might have been oversized, or in some cases undersized for that property. So we need to be calculating the heat loss of a property accurately to determine how much power do we need to put into that property at worst case scenarios. Which brings us nicely on to the next point. For boiler swaps, for situations whereby we're taking a boiler out and putting another one in, it also states that we should select a boiler that modulates down enough to the typical heat load of the property. So what that means is we need to be looking for things like minimum modulation. We need to be, if we've got a boiler that only modulates down to say 7 kilowatts, but the heat loss of the property is 4 kilowatts, then why would we be fitting that boiler? We want to fit a boiler that's got a minimum modulation much lower than 4 really, or because we want the boiler to modulate down, so we use as little gas as possible in the times when the boiler doesn't need to be putting as much heat into the property. So what we're going to do now is we're going to have a look at the board, and we're going to talk about radiator sizes. We're going to talk about the difference between boilers and heat pumps, and we're going to try and get more involved in the nitty-gritty as to what we're trying to achieve as an industry, and what this the updated British standards are trying to push us towards as an industry. So I've taken the liberty of writing out a couple of things on the board. First of all, summarising the points that I've already spoken about. Largely the fact that on new systems, as well as with existing systems, we should be doing an accurate heat loss for every property that we go to, whether it be for a full install or whether it just be a boiler swap. A heat loss calculation it's really important for every job we go to. We will be doing a video on heat loss calculations and showing you guys how to actually do them easily and effectively. There's nothing to be afraid of with heat loss calculations. They're quite a little bit time consuming, but besides that, they are the foundation of you delivering an efficient system at the end of the day. First of all, new heating systems should be designed to the relevant standards. That's what it states in the approved Part L document, and it also references CIBSE as part of it. Now, CIBSE's one is the Chartered Institute of Building Service Engineers, so that's the Bible for me. I mean, I always reference CIBSE. And we should design systems to a 55 degree flow rate. The idea is the lower the flow temperature, the lower the return temperature is going to be, depending on the heat source you're using. And the further we can get a boiler below 54 degree return temperature, the more efficient that boiler is going to be. If it's a heat pumps don't have to work as hard. The lower flow temperature that it's producing, they don't have to work as hard, so your efficiency goes up. Your SCOP and your COP will both go up. Boiler swaps, boiler modulation to the typical load of the heating system. We've spoken about that. Select a boiler with that'll modulate down low enough to ensure that you're not wasting energy. And inline filters should be installed, and systems should be cleaned thoroughly in line with British Standard 7593. It's important to note that all this information is only relevant to England. It's only relevant to England, and that's what the documentation states. Now, the main problem that we're going to get with designing systems to lower flow temperatures, especially with boilers and heat pumps, is the size of the radiators. That's going to be the biggest obstacle that we've got, because we're not going to just be replacing the heat source, we're also going to be replacing the emitters in the property. And if we're talking about radiators, that can be quite a difference. If anyone's out there fitting heat pumps now, you'll know if you're doing it properly and you're calculating them properly, the size of the radiators can be significantly larger than what they were for a standard boiler. So why is that? Well, let's look at an old-fashioned, well, not an old-fashioned boiler, a condensing boiler still, with an 80-degree flow temperature. Now, we know that boilers have a temperature differential between flow and return of 20 degrees. So we need to bear this in mind when we're designing the radiator circuit. So we've taken across the graph, we're using a room with a heat loss of 1 kilowatt, 1000 watts. So we've done it for a boiler at 80-degree flow, a boiler at 55-degree flow, as recommended by the new documents, and a heat pump at 55-degree flow. And what we're going to do is we're going to work out what the radiator sizes look like at the end of the exercise. I'm not going to do every single one, I'm not going to read it verbatim. However, this chart will give you an idea as to how you would size radiators accurately, not just using rule of thumb measurements that I've heard people using out there, because they don't work. So, boiler 80-degree flow, 1 kilowatt heat loss. We know that the DT between flow and return is 20 degrees. That's what we should be targeting as engineers on condensing boilers. This means that if you've got a flow of 80 degrees and a return of 60 degrees, the mean water temperature of your radiator is going to be roughly 70 degrees. Now, most radiator sizing charts, so from manufacturers, if you go to QDocs or Stelrad or whoever you're buying your radiator from, they will give you the outputs generally designed at a 50-degree difference between the room temperature, which is we're going to use 20, and the mean water temperature of your radiator. So if you take the mean water temperature of our radiator, so in the middle of the flow and return, so flow 80, return 60, mean water temperature 70. If you take the room temperature, 20 degrees, off of that 70, that gives us 50 degrees. Now that's what the radiator output charts are generally sized to, 50 degrees. Now, so we've taken our 50 degree, we are then going to take that and divide it by the chart data, 50 degrees, which gives us 1. We then times 1 by 1.3, which gives us 1. And then we then divide our heat loss, which is 1000 watts, by 1, which gives us 1000 watts. So we can see that for a boiler 80 degrees, 70 degree warm mean water temperature, we need a 1 kilowatt or 1000 watt radiator. Now that is roughly, depending on whose radiator you're looking at, a 600B700 P plus or type 21 radiator. That will give you roughly 1000 watts on that calculated, that catalogue data. Let's try it for a boiler of 55 degrees. We've still got the same heat loss, 1000 watts. We've still got the same DT of the heat source, 20 degrees for a boiler, condensing boiler. And we've got a mean water temperature this time, because we've got 55 degree flow, the return's going to come back at 35 degrees and our mean water temperature is going to be roughly 45 degrees. So then we take our room temperature off that, or our target room temperature, so 45 minus 20 gives us 25. Because our catalogue is based on 50 degrees, we divide the 25 by 50, which gives us 0.5. We then take 0.5 and we multiply it back to the power of 1.3. That gives us a conversion factor of 0.406. We divide our original room heat loss, which is 1000 watts, by 0.406, which gives us 2463 watts. Now that doesn't mean that we're looking for a radiator to deliver 2463 watts. It means that we need to select a radiator from that same catalogue based on a mean water to air temperature of 50 degrees. And we need to select a radiator that gives us 2463 watts that will actually, at the reduced flow temperature, give us the 1 kilowatt that we needed for our room. So just to put this into context and to put it into perspective, whereas with a boiler at 80 degrees, we needed a 600B700 P plus or type 21 radiator. Now at 55 degrees, we're actually looking at something more like a 500B1600 K2, which is considerably bigger. The other side of this now is, if you follow the same sort of rule with a heat pump, you end up with a 1751 watt demand or requirement. So that would be the same as a 6B1000 K2. So you can see the heat pump actually needs a smaller radiator than what the boiler does at 55 degree flow, and that's because the delta T, the difference between flow and return for a heat pump, is generally 5. Some say it can go up to 7, but you want to be targeting around about 5 degrees. So that sort of puts into context some of the problems that I foresee with sizing boilers at 55 degree flow. I mean, the other side of that, and which if you wanted to turn it into a positive, would be that when that property then moves across to a heat pump, you could actually run your heat pump at a lower temperature because your radiators would already be oversized for that heat pump. So you could get a more efficient system out of a heat pump because you'd lower the temperatures. But this gives you an idea as to some of the reasons why low temperature heating is, you know, really efficient, but some of the problems it might cause. As engineers, you know, customers generally don't want big radiators, and we need to be looking at, you know, how we size them effectively. So yeah, hopefully this will give you some form of an idea as to how the radiator side of things works when we're looking at lower temperatures. With heat pumps, you also, because they've got a lower DT, you also have to think about pipe sizing. However, it's not a massive issue. However, you do need to design systems correctly. Generally speaking, anything up to 9 kilowatts, you should be able to get away with 22mm supplies, or primaries if you like. Microbore, you really need to be careful of anything off microbore really. But yeah, pipe sizing, we need to think about that with heat pumps a lot more. Generally with a boiler you'll be okay because you're still working off the same DT of 20 degrees. But your radiators, if we're going with lower flow temperatures, we need to really start thinking about radiator sizes, which is fine, but you've got to have that customer, that education piece with your customer. Explain that, look, the radiators aren't going to be as hot, we've spoken about this before, and that your room will still be adequately heated. However, your radiators will be bigger in order to allow that to happen. So just to recap what's changed, let's not get worried about this. System cleaning and filters, we should have all been doing that anyway, really. We shouldn't be fitting brand new heating systems or brand new boilers onto dirty systems, causes a multitude of problems. Systems should be cleansed thoroughly and protected with system filters. Heat loss calculations, we're going to be forced down the road now of being much more considerate of heat loss calculations. We need to be using them a lot more. We should be doing them for every job. Every job now should have an accurate heat loss calculation so that you know what heat you need to deliver into that property. We can't use rule of thumb calculations anymore, really. We can't eye up windows and say that size, but radiator will fit under that window. That's just a really poor way of doing it. 55 degree flow temperatures, so we need to start thinking about radiator sizes a lot more, because you can see from what we've already gone through, it can make a considerable distance. And yeah, basically making sure that we're referencing design guides more, we're using the information that's available to us, and that's pretty much it, guys. It's not scary really when we think about it. Everyone seems to be panicking about it. This is not something we need to be worried about. A lot of it is stuff you've already been doing or should have been doing. I realise that, you know, heat loss calculations can be quite daunting. However, we will go through and we will do a video on heat loss calculations in the near future for you. And that will allow you guys to go into a property and, you know, really be much more confident about what you're going to be fitting. Take the guesswork away completely. Okay, guys, so
can I just add just to that as well, just one thing that might be important to consider, is boilers with low modulation. So it might be now important to actually look at what boilers we're installing, and if we're going to install a boiler that's going to modulate down to the load of the system. So if we put the combi boiler in a flat and it's got a 3 kilowatt heat loss, we're not going to fit a boiler that only can modulate down to 5 kilowatts.
Exactly. Yeah.
So yeah.
So 100%. If you've got a property, exactly like Alan says, that the heat loss is generally designed to the worst possible day outside. So -2 up here in Yorkshire, -2.2 degrees or whatever it may be. So that system, when it's, you know, anything over to -2.2 outside, you don't need that heat, or whatever it may be, 7 kilowatts, 8 kilowatts, whatever it may be. So you need to select a heat source that will modulate down, so that in those warmer times of the year, you're not using gas that you don't need to be using. And we've done a good video on controls and open therm and whatnot that covered this quite well. So this is something we need to be thinking about. So selecting a boiler and selecting a heat source that will modulate down, so that we're not wasting energy, and customers aren't paying for a lot more gas that they don't need to be using. And we want to really be maintaining the system efficiencies and the comfort levels for our customers. Thanks guys. Any of the videos that you want us to do, please let us know and we'll be more than happy to do that for you.
Thank you very much for that, Michael. Just a recap on all that. What do I take from it? I think we should be sizing central heating systems, and back many years ago when I used to work for British Gas, we used to size when we used to go and install new systems, even new radiators. We used to size the rooms and size the radiators correctly. So I think that we should be doing that anyway. It seems to be, over the years, you just go to merchants and you just buy a pack and you buy up radiators and you just try and make whichever radiator fit in which room, which is not good enough. When I did heating systems personally, I would size the rooms and I would try and get the right size radiator. But because now we're going to low temperature, obviously even the radiators I installed in the past, they wouldn't be big enough. So what do we take from it? We're going to have to install bigger radiators. Will people do it? I hope so. I don't, if I'm honest with you, I just think that what'll happen is, I think the people that do a good job will struggle to get work, and all these regulations, what they do is they make it harder for the people that try and do the job well. And then I think that people that don't do such a good job, they'll get as much work as they want, because obviously they'll be cheaper and they'll just do it however they want. What I hope will happen, I hope that some customers and some end users will see videos like mine or like what other people will be doing, and they'll think, well, it's worthwhile us getting them bigger radiators because that's going to reduce our energy bills. And obviously with the current climate, energy bills are skyrocketing, and if we're honest, they're probably going to even still go up more, you know, and over years they're likely to go up and up and up. So I think that more people are looking at that now. So hopefully some customers will be like, we just want the best system we can have. Let's pay for it doing once. Let's pay for it sizing correctly. The other thing I take from it as well is we're going to have to be really careful what boilers we install, because when you look at some boilers, some of the Baxis, I will mention Baxi, the low modulation on them is about 6 kilowatts, roughly. So what that will mean is, if you've got an house, say you've got a typical house that's 7 or 8 kilowatts at maximum when you need the most heat, when it's -2. Through the year, you might only need 3 or 4 kilowatts maximum for that house. So in use, when you're using it, might only need 1 or 2 kilowatts. So your Baxi is going to be miles oversized. So according to regs by letter at law, you won't be able to install one of them boilers. So it's going to be, you know, something that we're going to have to consider. Manufacturers might start altering their boilers to modulate down more. So I know some boilers like the Ideal Vogue, I think that goes down to 3.7, something like that, which is better. You've got your Wiesmann 200, I think that goes down to, and this is off the top of my head, I think it's a 17:1 modulation, and I think it goes down to about, I don't know if it's 1.7 kilowatts. So it may be that boilers that are a little bit more advanced, that you can range rate and that do modulate right down. It may be that customers start thinking about installing things like that. And it may be that installers do as well. Yeah, that's my take on it. Please put your take on it below. Let me know what you think, and I hope you've liked this type of video. We are going to try and do some more videos like this. We're going to try and do some heat loss, so you will know how to calculate a heat loss for a property. So you'll know how to calculate the radiator sizes. We're also going to do videos on sizing low loss headers and what low loss headers are. Yeah, we're just going to try and help you as much as we can. So yeah, thanks for watching.